Ms. Neha Shrotia. Now, please you share the screen and just discuss with the lab session.
Okay, thank you so much, sir, for introducing me, and I feel very grateful for the to be taken part of this FDP. And hello, friends and participants. My name is Neha Shrotre, as I told you, and today we are going to start our session over lasso regression and bridge regression. Am I audible properly? Am I audible properly,
Yes,
Suren
yes,
sir?
perfectly fine.
Oh,
Yes, fine.
Oh, okay. So we are now going to start first about the ridge regression and the lasso regression. So as you all know that these two popular techniques in machine learning is used to regularizing linear model to avoid overfitting and improve predictive performance. So in today's session, we are going to implement the ridge and lasso regression both in the Google Colab. So let me first share the screen with you all. Um, Wait a minute. I'm sharing the screen with you all. Please tell me if it is visible or not.
Yes, visible.
I think it is visible to all.
Yes, visible perfectly.
Okay. Okay. So, first of all, I want to explain what is ridge regression and how it works. And other than ridge, we will learn about the lasso regression also. So, as you all know, that you have already completed the linear regression session in the last sessions. So, ridge regression is also known as L2 regularization because it adds the squared magnitude of the coefficient as a penalty. And if we talk about the lasso regression, so it is also called as the L1 regularization. It is also a linear regression technique that adds a penalty to the loss function to prevent overfitting. I think overfitting is also known to all. This penalty is based on the absolute value of the coefficient. If we talk about the ridge regression, so ridge regression is technique in machine learning which is used as the regularization linear model, and it to improve predictive performance of the data set. Both models like ridge and lasso regression, both models add a penalty term to the model's cost function to constrain the coefficient, but they differ in how they apply this penalty, right? In this session, we are going to implement ridge and lasso regression, both the regression in this Colab file. And for this, I have taken one data set. This data set is about the salary data set. If you want to see the data set, I can share the data set also. Let me share the data set first. I am sharing the data set with you all. Is it visible?
So have you shared the data set in the chat box?
Is it visible to all?
Not yet. Okay.
Yes, this is our salary data set. In this, you can see we have multiple columns and multiple rows. And in so many cells, you can see like missing data is also there. Like somewhere the salary is missing, somewhere the PSD option is missing. Okay, so you can check the data set first. Then we will implement this in the GoLab file. So this is our data set. I have taken a short data set for this application. So I think all are the familiar with the linear regression data sets, and this is one of them. In this, you have checked, you can check rank, discipline, PSD, services, gender, and salary, right? So we can check first the like which type of data set is there, and how which type of data values are in there in the data set, like. And here we can see like in this cell, salary is missing, and in this cell also a number is missing, right? So this is the data set we are going to implement in the Ritz and Lasso regression, right? Now let me share the collab file again. Yes. So come over the implementation part. So in this collab file, the code is running Ritz and Lasso regression. So first, as you all know that first we need to import the libraries in Colab, like import pandas, import NumPy, and we are using sklearn model in this. So we will import the sklearn model selection files also, linear model file also, right? So these are all the libraries which are which I have imported in the Colab file. Now I need to read my data set, right? So we have number of options to read the data set. We can write the code so that we can upload the data set, or you can directly upload it on the Google Drive and can fetch or can mount the drive in the Google Colab file, right? So in this, I have written the code so that I can upload my data set here. So from google.colab import files, upload file dot upload. This code is going to upload the data set in this Google Colab file. So I can choose the file from my system. In this, I don't I in this we are not required to upload my data set in the drive. Sometimes we have limited limited memory space in the drive, so we cannot upload the data set on the drive, so we can directly choose it from our system. So I have written the code for this, like we can choose this file from the system directly, right? So I have uploaded my data set in through this through this code, right? Now, as you all have seen like my data set, so either uh, we can use the code for the data cleaning, so that we can arrange our data, we can remove our missing values or from the data set. So this code is going to clean our data, and the other cell will remove the missing lines from the missing rows from the from the data set. Like I said, like salary is missing, like PSD option is missing, right? So we can remove the missing values from missing rows, missing values rows from the code. Like in this, uh, we can use Dropona also. Dropona is also used for the removing missing values. Next, come over this code. In this, we can give the column number, or we can give the choose the columns in which we are going to perform the RIDS and lasso regression. So I am choosing the rank, discipline, and sex from the data set to use RIDS and lasso regression. And in after that, I encoded a category of variable. In this code is used to mm, convert the column numbers into the category, like 01 format. We can change the 01 format in this, and then we can split. We can split our data set into train and test value, because whenever we are going to whenever we are going to implement linear regression or any model of the machine learning, so we need some data for the training, and we need some data for the testing also. So whenever we use any model of machine learning or deep learning, we need to split it into the test and train models. Like, so in this way, I have taken two variables like x and y, and both the variables are used for the train and test values, right? So in this, I can write x equal to df encoded drop salary exit. In this, I can divided the data set into x train, x test, y train, y test, and split the data set into testing and training data. Now come over the linear regression model. We will perform a linear regression model in this. So linear regression model, uh, mm, linear regression model, it measures how long training takes. Like it will give you the time period, in which time period it will completed the training part, and it uses the trained model to predict the outcome on the test data. So we will start time. It will give how long training takes, and then it will predict the outcome on the test data. And in this, we will measure the MAC and R2 value also. MAC stands for mean square error, and it analyze the error and tells the tell you the error magnitude. And R2, or you can say R square, tells you the fit quality, how well your model captured the data trained. And which this is the part of the linear regression model. In this, we calculate MAC and R2 value. So here you can see, like according to data set, we have received the MAC and R2 value. MAC is 331053. Like these are the values we have calculated through the linear regression model. And now we will implement the lasso regression over this. Lasso regression, as I told you, like the lasso regression is use and apply L1 regularization, adding a penalty term proportional to the absolute value of the coefficient. And we know that, like feature selections, to perform automatic feature selection. Less important predictors are completely excluded by setting their coefficient to 0, right? In this lasso regression, in this we see like regression is a version of linear regression. So it include a plenty equal to the absolute value of the coefficient magnitude. And L1 regularization is a term which is used to reduce overfitting and help some coefficient to be absolutely 0. Hence, we can say the standard loss function, or we can say mean square error, is modified to include a regularization term. Right. In this, we use loss equal to mean square error plus lambda and w, which is used for the coefficient, and the lambda will be representing a regularization parameter in this, right? So I think that the theory part is already completed. So you can understand the which formula we can use for the loss, like loss equal to mean square error plus lambda and w, which vary from the I equal to 1 to n, right? So w will represent the coefficient value and lambda is representing the regularization parameter, right? So lasso regression is ideal when we suspect that only a few predictor are truly important, and the rest may add noise or redundancy. It perform like automatic feature selection by shrinking the coefficient of less important predictors to zero, effectively removing them from the model. Like like this we can perform the like this we can perform uh, the model in this lasso model in this. So here we are implementing lasso regression. In this in this you can see lasso equal to lasso alpha equal to 1.0. What is 1.0? So in this we can say like initializes a lasso regression model with a regularization parameter alpha of 1.0. And lasso regression is start the time and train and lasso model on your training data x train and y train, and it measures how long the training takes time na, how long time training is taking. And after that you can see YPRED LSO predict, ठीक है, X test. So it uses the trained model to make predictions on the test data. X test we are using for the testing data. Next we are calculate two matrices here, mean square error and R2 score. So mean square error, you know mean square error is measure the average square difference between actual and predicted value, and it is lower in this. If we got the lower result, lower value, so that value can be calculated as the better value, right? And in R2 score, indicating how well the model explain the variance in the data, that is ranges from 0 to 1. And one is also predicted as the perfect fit, or if we are receiving 0, that will be the poor fit. Getting this? So in this you can see lasso regression is using, and we are getting the value lasso regression MSE is this, and lasso regression R2 is this. So this is uh, lasso regression model. Now we are come over the ridge regression. So in this ridge regression uh, we can check that ridge regression is implementing, and code we have written the code, and in this we can see like model creation. Ridge alpha 1.0 creates a ridge regression model with a regularization strength, and alpha is set to 1.0, right? Am I audible?
Yes, audible. Yes.
Okay, okay. So in this we can say कि ridge regression help prevent overfitting by adding a penalty to large coefficient. Now come over the training part. The model is trained using your training data X train and Y train, and the time taken for training is measured. And prediction, the trained model predict the target value of your test set X test. And evaluation for the mean square error and R2 score is measured. Like as I told you in lasso regression also, like mean square error is nothing but the measures the average squared difference between actual and predicted values. And in this also we can say like lower value is better than the upper value. Okay, so R2 score in this also we can say like zero is poor values, and one if we getting one then it is the higher is if we getting one then it will be the perfect fit. So R2 score is nothing but the indicate how well the model explain the variance in the data. Or in this also we have the output like ridge regression MSE is this, and the ridge regression R2 value is this. So these are the models, ridge and lasso regression. I think in these models are clear to all. If anyone has any query in both the implementation part, lasso regression or ridge regression, you can write your query in the chat box, or you can directly ask me. We can discuss over this, or you can write in the chat box. I think both the models are clear to all, and you can understand what I'm saying, how we can measure MSE, mean square error, and the R2 score, and how the results are predicted. I think these both models are clear to all. Now come over the efficiency training time. So we can directly print, yeah, directly measure the training time only right after writing print linear regression training time, LR time is, and this is the simplest model, and this is the simplest way to check how much training time they are using. So in linear regression training time, actually you can see like we have implemented three models over this code, like linear regression. First we have implemented linear regression, then we are implemented the lasso regression, and the another one is the ridge regression. So we are measured the efficiency for all three models, um, linear regression, lasso, and ridge regression. So you can check the training time for all three models here, right? Now, final test result table. So here we can find test result table. So we can find the result in the tabular format, and we can receive model, MSC, R2, and train time, all these parameters in the one table. So here I can show you the answer, or we can say table for each and every column which is mentioned in the data set earlier. So this is the model comparison. You can check linear, lasso, and ridge regression, model 1, MSC, R2, and training time. All three parameters are calculated in this for these three models, and coefficient are also there for linear regression, lasso regression, and ridge regression. Right? These are the simplest model to perform for the on the Google Colab, and you can find data set also easily. Number of data sets are available. You can perform both the models over any data set which is available on online. I have taken one simple data set. So I think the model is clear to all, and the implementation part is also clear to all. If anyone has query, we can discuss here.
Yes,
Okay,
participants.
so lasso regression, if we talk about something also about the lasso regression, so we can say like it is a classification algorithm that uses shrinkage in simple and sparse model. Like in shrinkage, data values are shrunk towards a central point like the mean. And lasso regression is also regression algorithm that perform L1 regularization, which adds a penalty equal to the absolute value. And if anyone wants to, if I am asking the question to you, if anyone know about the full form of lasso regression, you can tell me over the audio or over the chat box. What is the full form we use for the lasso regression? This is the simple question from this topic. If anyone has the answer, you can write in the chat box, or we can discuss over the audio. Lasso regression. What is the full form of lasso regression? Okay, I got the answer. Thank you, Mr. Panda, thank you. So right, the answer is right. Lasso regression is stands for the least absolute shrinkage and selection operator. And lasso regression is also good for the models, showing uh, high level of multicollinearity, or when we want to automate certain parts of model selection, variable selection, or the parameter elimination. So lasso regression is a solution are the quadratic programming problem that can best be solved by with the software like RStudio, MATLAB, etc. It has the ability to select the predictors. So I think lasso regression is uh, more faster than the linear or grids regression. Is there any other question? Mr. Feroz, do you agree with my answer? Okay, thank you. And if anyone has any question, you can write your question in the chat box, so we can discuss uh, the questions in this session.
Hello. Yes, Mohammad
Okay,
Firoz Alam.
regularization. Okay, I got one question from Mr. Feroz. Exact meaning of this. Explain. Okay, regularization. Regularization. Maybe we can define it as the modification, or we can say change in the learning algorithm that help to reduce its error over the test data. Like regularization is a simple term which is used to modification, or we can say changes for the data set. No? In this, we can or we can say generalization is also a term which is used for the modification also. So in learning algorithm, there are many variants of regularization techniques, each of which tries to cater a different challenges. So regularization is nothing but the modification and changes which can be done over the data set, which is used in the machine learning models. Or we can say like in deep learning, regularization is nothing but the strategies revolving around the regularizing estimators, and we can say like we can change the models as per the requirement. Regularization of an estimator works by the trading increase biased for reduce variance. So it is the effective way to modify, or we can say change our data set according to our need.
Hello, hello. Am I audible? Okay. Hello, am I audible?
Am I audible? So if there are any more question is are remaining, you can ask.
Hello, participants, if you have any doubt, then please write in the chat box. Am I audible to you?
Okay, okay, we are waiting for the questions. Am I audible?
Yes, yes. Audible.
Okay. Okay, there
So
is a
this,
question in the chat box about least absolute shrinkage and selection operators. So, what do you want to ask about these two operators? This is actually the full form of lasso regression, and I have explained about the lasso regression earlier also. But if we talk about lasso regression again, so lasso regression is algorithm, or we can say it is a model that is used for the machine learning algorithm, and lasso regression is good for models showing high level of multipolarity, or when we want to automate certain parts of model selection, variable selection, or parameter elimination, we use lasso regression. And it is better than the ridge regression. We have discussed it also earlier. So lasso regression is more useful as compared to ridge regression. It is also called as the level regularization. And it in this we remove the problem of overfitting and feature selections. So, Sunil sir, I think no more questions are remaining.
Yes, yes. Okay, absolutely fine. Yes. So this regularization is a kind of three variants regularization. The first one is a ridge, second one is a lasso, and third one that is a elastic net. So this ridge regularization, so better to use the ridge regularization in case where you uh, know the features are very important and you don't want to lose the input feature. So in that case, just you apply the ridge regularization, and the lasso regularization, if you know the data set that some of the input features are not so important, then just better to apply the lasso regularization. And the third category is if you don't know, means any of the input feature, you don't know the data set, which one of the input feature is important and not important. Okay, so in that case, just you better to apply the elastic net regularization. And regularization actually is a uh, uh, one way of technique to overcome the overfitting. In this regularization, just we add the extra term. So now see this decision tree. Here in the decision tree, we do the pruning. So pruning is a another way to overcome the overfitting. Okay, this is also a regularization. And the third one that we can understand this regularization in the deep learning, we used to use a dropout. So dropout is also that is just to overcome the overfitting. So dropout in the deep learning and pruning that we use in the decision tree, and this extra term if we add in a regression, so these all are the things of regularization through which we can just overcome the effect of overfitting. So regularization means not only just we add the extra term in a regression. Okay, so this is not only the one way of doing the regularization. This is not the means one way to overcome the overfitting. So in the decision tree also we can overcome the overfitting by doing the pruning, post pruning or pre pruning. Okay, deep learning also we can do the regularization through dropout. So these are the things just you need to understand the this concept of this regularization. And rest, if you have any further doubt this regularization, then we can discuss.
Yes, sir, we have time remaining. We can discuss some questions also. If anyone has any query, you can ask in the chat box.
So if you don't have any query, any doubt, then you please write clear in a chat box so that we can wind up the session. Here.
Sir, you are not audible.
Hello, yes. So I'm saying if again, yes. So participants, if you have any doubt, query, then please write in the chat box. Otherwise, just we wind up the session here. Okay, okay, fine. So thank you, no, for taking this lab session. Thank you very much. Just coming and accepting our invitation. Thank you very much. So in near future, if any FDP that will be there, then definitely we will call you again. So thank you very much for taking this session.
Thank you so much, sir, for giving me this opportunity. And sorry for the inconvenience, which is, I think I am facing issues also right now also. But
Actually, it
these are the
happened in the
technical issues.
online.
Can
In the
yeah.
online, it happened. This voice and audio, this sharing the screen is okay, no issue. Okay. Okay, so thank you very much, participants. So now just take a 5 to 10 minute break. Then we will start this closing ceremony valedictory session at 4:15 p.m. Okay, so thank you very much. Thank you. So that's all from my side.
Thank you so much, sir.